Hello and welcome to this video on the Coal Mine Meeple puzzle. So this is the explainer where I'm going to go through the problem, explain what it is, and give a little bit of intro to the two levels that we have for you to code. And then there will be a separate video on the solution, how to solve it. But let's dive right into the problem here. So we call this the Coal Mine Meeple problem or puzzle. So these are the meeples that we see here, and the coal mine is represented by this playing field here. So we have indexes for the squares 0 to 11. There are 12 distinct squares, and it kind of looks like an E, I guess. This was in some newspaper a very long time ago, and that's where I picked it up from Googling, I think. And I turn it into an exercise on our page here. So what is the problem that you should solve? Well, it looks like something like this. So we start off with the red meeples on top and indexes 8 to 11, and the blue ones at the bottom 0 to 3. And basically you should switch them around. So in the end we want all the blue ones to be on top and the red ones to be at the bottom on squares 0, 1, 2, 3. And you're going to do this by a series of moves, and this is of course a very cramped space here for the meeples. So but basically you have to move them one by one. They can never clash. I mean, if this one goes down now, it could not go down here because there's already a meeple there. You can not move diagonally also, so this one can also not go here. It can only move in the cardinal directions or orthogonally like this. So the problem is then to use this very cramped space that you have here, and I'm going to show just a little bit of how it can look. Something like this, starting to get some blue meeple up, then maybe focus on the blue ones for now and go with this one here, and then slowly get to a situation where you have and how do I get this one in the, maybe now I can do something like this, and this one goes here, this one goes here, and so forth. So work to start to fill the top squares with the blue ones, and eventually the red ones will go all the way down here. Yeah, this is how it should work, something like this. Now I kind of want to do the whole solution here. Let's see, maybe I can do this. Now we have the rightmost squares fixed, and yeah, maybe go like this. It's not that long solution. Maybe now I will solve it actually. So now these guys can go up. I think I followed all the rules. Feels like it. Yeah, now we're close to the end here. Like so, and then this one can go up here. So that's how you solve it. And of course, in this exercise, you should mainly solve it using code. So you can, of course, start with a ChatGPT solution or write it yourself. Maybe do it with some kind of tree search. So what I mean with that is that you have a node here with the state of the current board. So this could be, I guess it's this is the flip side. This is the end position, but let's pretend they started like this. Then the node here would be this state. And then you do moves. In the beginning, maybe there are only 2 possible moves. And then you do new nodes in the tree with a new state. So, for example, if this guy would move up, then we have a new state. And then you keep doing this. And in the end, there will be more possibilities here. And I think actually the tree will be kind of large. What you also need to do then is to have strategies to not visit the same position again. So you should have some kind of cache, maybe a set with all the states that you have seen so far, so that if you realize that this one, actually I went back to the same state as before, then you cut the tree off in those locations. And then you need to have some kind of check so that in the event that you actually find a solution, then you return that, and then you should return the whole path, the whole path like this, how you reach the solution. So that will be something like that will be the end goal with the code. If we look in our interface, we have 2 levels actually. So in level 1, it's mostly about not really solving so much, but more figuring out how to move the meeples. So you will use the indexes a lot, 0 to 11, and here it says reach square 11, and we also give all the square pairs where the meeples can take steps. So basically it says 0 to 1, 0 to 1. Yeah, those 2 squares are connected. 1 is connected with 2, 2 is connected with 3, 4 is connected with 5. So basically it's a graph of all the possible moves that you can make. So if we look, if we look here on the whiteboard again, the idea is that, so you have these squares here, let's draw them white, and basically you use a graph data structure, so that's at least one possibility. So wherever these ones are connected, so maybe you have a class for a square, and then you connect the squares, something like this, going also up here, etc. So that's what we're trying to give here. There are actually 4, 8, 9, 10, 11 edges between nodes in this graph here. And then, so you need to have a representation in your code for how this graph should look, and the start state where the meeples are. And then try to have some either recursive method to build a tree structure to search for a solution where they have switch places, or you can do it iteratively using like a list or a queue, where you work off of the possible states that you are still to explore. And when I say that, I mean the parts of the tree that remain so here maybe you have found that you have already visited those nodes by using a cache, but you will also have some nodes like here, 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 that you still haven't explored. So it's about building the tree downwards until you reach kind of dead ends when you get back to states you've already seen, or in the end when you go all the way down, and this might be some 30 levels down, 30 moves or so, even more. Look for when you have the solution, when they have all flipped sides. So yeah, that's the task here. But if we start again with level 1, you should only reach square 6. So in level 1, maybe you need to build the data structure for this to represent the playing field, and do some method to make moves. I've actually done a manual solution here just to try out, so I understood the problem or tested the problem. So basically the return list that you give is one long list of integers, indexes, and they actually work pairwise. So every odd or even, this is index 0, so every even index is the from, and every odd index is the to index. So the first 2 integers here means to go from 1 to 4. Then we go from 4 to 5, continuing on here. Then we go to from 5 to 6. 5 to 6. And then I have some extra here, which we actually don't need. We could remove those. So if I run this for level 1, let's see how it looks. Then we get the full 10 score because we got a meeple to square 6. So this one just required 3 moves for the blue meeple to go 2 steps up and then to the right. That is level 1, so that's mostly a practice level. The tricky one, and why this is a hard problem, is when we go to level 2. So here I've actually also right now entered a manual solution, something like what I did on kind of the whiteboard or the other screen. So if I run this now, it will be a valid solution, but I haven't used a tree to solve it. I've just manually input moves like I just showed you. So this is something close to the manual solution I did before. but it shows a way to solve it, and maybe not the most efficient way, but at least one way to solve it. So the task is to do this with code instead of manually. So again, I did something like putting the blue ones there and the red ones there at the ends, and then actually not that much remains now to solve it. Just need to get that one down, to this state here, and that is a solution. So the task is to write the code to create this list from the code and from some kind of tree search likely, instead of doing it manually like I did here. So that is the Coal Mine Meeple puzzle. Good luck solving it.